Hey guys, and welcome back to another video on the channel. In today's video, we're going to be covering the Specialist Mathematics Paper 2 Tech Active Multiple Choice Booklet for the 2023 paper. This is for the QCAA syllabus, so Queensland Australian students. You can be using your Casio FX-CG50 calculator for this one here, and it is recommended for calculator because a couple of these questions will be using statistics, and you won't be able to solve it without it because there'll be a couple of rounding involved, okay? But anyway, let's get into the first question pretty much. So, question 1. The acceleration of an object moving with simple harmonic motion is modeled by A equals negative 2.95x, where x is the displacement in meters from the origin. Determine the period of the motion in seconds. Okay, so simple harmonic motion is pretty much an object oscillating between two different points. So, if you look at your formula sheet, you know that pretty much acceleration is equal to negative omega squared x. So you can see here from this particular model that omega squared is 2.95. So omega squared is 2.95. And if you were to be using your formula sheet, you would know that pretty much the period is equal to 2 pi divided by omega. Okay, so if we work out what omega is, we can then work out what the period is. So to work out omega, you would just square root both sides. So omega would be the square root of 2.95. You would chuck that into your calculator, and it should be roughly, well, I won't round it to a couple of decimal places. I'll leave it as a third. So it'll be the square root of 295 over 10. Okay. So then you can substitute this bit of working here into this formula here to work out what the period would be. So the period would be 2 pi times pi, and I'm going to write the reciprocal because it's division, so it'll be 10 divided by the square root of 2.95. And if you chuck this into your calculator, you're roughly going to get about 3.658. And then if we look at our answers here, we can see that doesn't match, that doesn't match, that doesn't match, and you can see this answer looks about that. So if you round that to two decimal places, that actually works out exactly. So the correct answer for D is question 1. Okay. You'll see this on your formula sheet for the QCAA syllabus for specialists, and you've got to pretty much make that connection there pretty much, okay? And that's how you answer pretty much the first question. If you have any questions at all, just leave something in the comments and I'll try my best to answer it, okay? Let's take a look at the next question. So, the standard deviations for the scorers of 1,000 students completing an entering test at a certain university is 13. A researcher takes repeated random samples of the test results, with each sample comprising of 40 scores, and calculating the mean scores of each sample. Determine the standard deviation of the distribution of the sample mean scores. Okay, so on your formula sheet, you're given this particular formula. So the standard deviation of a sample is the standard deviation of a population divided by the square root of the sample. Okay, so n being the number of people in that sample. Now, a lot of people are going to go and chuck 1,000 for your n, okay? Now, if you do this, and you put the standard deviation as 13 on the top, you're going to get 13 over the square root of 1,000, and that should give you about 0.41, which is one of the answers here, but it's definitely the incorrect answer, because that is pretty much not a sample. That's all the students taking the entries test. The sample is the 40. So the correct answer wouldn't be n equals 1,000, it would be n equals 40 instead. So make that substitution there. So you would get 13 divided by the square root of 40 instead. And if you chuck that into your calculator, you're going to get approximately 2.055. Now if you round that, you get 2.06, which is actually the correct answer here. So the correct answer is B, but you can see here they've put one incorrect answer because that would be a common thing students would put up. These other two, A and D are throwaway answers. They kind of just put there to pretty much match things up, okay? But you can see you've put two answers here, one that could be correct and one that is correct, okay? Right, let's move on to the next question. So, question 3. Given that 2i is the root of z squared minus pz minus q equals 0, determine p and q if they are real numbers and determine the values of them, okay? So, with this one, we know with a complex polynomial that a conjugate is also the root of a polynomial. So if z equals 2i is a root of the polynomial, then so is the conjugate. So the conjugate is just the opposite sign of pretty much the complex number you have here. So let's say if z equals a plus bi, then the conjugate of that would be a minus bi. So the opposite sign of the complex value. Okay, so if we know that is a solution, then the conjugate should also be a solution. So negative 2i is also a solution. Now from here, we know that this quadratic is pretty much comprised of the two factors multiplied by one another. So z minus 2i and z plus 2i are factors of this polynomial here. So if we multiply them together, you're going to work out what this polynomial is. Okay, so if we multiply them together, we're going to have this term here times by this guy here, and this guy here, and this guy here. So this will give us in turn z squared plus 2i minus 2i, oh sorry, I forgot the z's, 2iz minus 2iz, and then negative 2i times by 2i, so it's going to be minus 4, but don't forget about the I, so it's going to be I squared. Now, because I is the square root of negative 1, therefore I squared would also be negative 1. So you have negative 4 times by negative 1, which gives you positive 4. So you have z squared plus 2i z minus 2i z plus 4. Now you can see here, these terms in the middle cancel out because they're the opposite signs of the exact same thing. So they can cancel out. So what you're going to get pretty much is z squared plus 4. Okay. Now if we match that up with the polynomial we have up here, we can see there is no middle term. So that means p must be 0. Okay. So if we were to write it in here, we have z squared plus 0z plus 4. So we can see p is going to be 0. Now, if you take a look at how they've actually laid out the quadratic complex variable equation, we can see that they've written it as negative q. Okay, so we can associate that positive 4 is equal to negative q. So negative q is equal to 4. Therefore, q must be negative 4. So q is negative 4 and p is 0. Now we don't care about the sign here because it's 0, it doesn't change. So all we've got to do is make that right connection there. So we look for the answer that has q is negative 4 and p is 0. And we can see c is the correct answer there, and that's it. If you have any questions about this particular question here, leave something in the comments and I'll try my best to answer it. Let's move on to the next question. So question 4, the position of a particle can be modeled using this vector equation. So r equals cos ti minus 2 sine t j, and t has to be greater or equal to 0. Which curve best represents the path of the particle? Alright, so with this guy here, the parameter they've used is t. So the reason they've used t is because t represents time, so that's why they've used that as your parameter in this equation here. Now, what we have to do is convert it to Cartesian equation, because you can see in all of these guys here, they're x's and y's. They don't have any t's and there's no vectors involved at all. Okay. Now, to convert to Cartesian, we have to break up the components into their equation. So this is your x component. So x is equal to cos of t. This is your y component. So y is equal to negative 2 sine of t. So we need to substitute these two equations together somehow to get some Cartesian result. Okay. Now, an identity we can use on our formula sheet is Pythagorean's identity. So sine squared of any angle plus cos squared of any angle must be equal to 1. Okay, so what if we use the exact same thing? So we've almost got cos t and sine t by themselves. All we have to do is move the negative 2 onto the other side here. So you could divide by negative 2. So at the moment, oh, I've run out of room. So we're going to have x equals cos t, and we're going to have y, or negative y on 2 equals sine squared t. So if we were to rewrite this rule, we'd have sine t squared is sine squared t plus cos squared t is equal to 1. Now sine squared t just means sine t all squared. So if we substitute this bit into here, and if we substitute this bit into here, this is what we'll get. We'll get negative y on 2 all squared plus x squared equals 1. Okay. If we apply the square to all of this, we'll get y squared on 4 plus x squared equals 1. Now we can see here, this is the equation of an ellipse. So these first two ones, A and B, these aren't ellipses. These are just like some weird hyperbolic curves pretty much. So it can only be between C and D. Now, the difference between the two of them is which way has been stretched further than the other. So pretty much an ellipse is a circle, but it's been stretched more so in a horizontal direction or vertical direction. Now, if we can look from our equation here, there has been a stretch in the vertical direction, so the y direction. So obviously D is going to be the correct answer because we can see here it's been vertically stretched by 2 here. So if we were to find the y-intercepts of our equation here, we would set x equal to 0. So if we did that, we would get y squared on 4 equals 1. So therefore you get y squared equals 4 because you can multiply 4 on both sides, and you get y equals plus or minus the square root of 4. So y is plus or minus 2. So we can see those results match perfectly. So the correct answer is D. Okay. And that's how much you pretty much solve this one here. So if you get given a vector equation and it has sines and causes, you want to be looking at your formula sheet with the trig identities because you want to make this substitution fairly quickly. Okay. Because remember, these multiple choice questions, they're only worth 1 mark each. So you only want to be spending a minute on them. Now this question here takes more than a minute to do. But some questions like this one up here would probably take you less than a minute if you're very familiar with simple harmonic motion. Okay. And yeah, that's about it for question 4. Let's take a look at the next one. Okay. So a plane contains the origin and the points 1, 2, 3 and 3, 2, 1. They probably did that on purpose, I reckon. A vector normal to this plane is blah 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 blah. Anyway, so we know the origin is here. So what we can do is draw our vectors here. So this is 0, 0, 0. This is 1, 2, 3, and this is 3, 2, 1. Okay. Now, if this is a plane, how we define a plane is the vector perpendicular to it. Okay. So let's say this is vector A, and this is vector B. We define it by working out this vector here, our normal vector. Okay. Now, this vector also down here is your normal vector. It's just in the opposite direction. Now, the way we work this out is via the cross product. So you need to cross this vector with this vector here. Okay. So let's just say A is 1, 2, 3 and B is 3, 2, 1. So it's going to be A cross with B. Okay. So the way you set this out is in a 3x3 matrix, but you're finding the determinant of it. Okay. So on the top you're going to have I, J, and K, and then you're going to place the A vector first. So the X component is 1, the Y component is 2, and the Z component is 3. Then for B you're going to do the exact same thing. So X, Y, and Z. So 3, 2, 1. Okay. Now we've done that, I can rub out my lovely picture and we can pretty much start working out the cross product. Let's just get rid of this. So I'll just write it up here. So determinant of I, J, K, 1, 2, 3, 3, 2, 1. Let's get rid of this because we don't need it anymore. Now when you're finding the determinant of a 3x3, you need to break it down into a 2x2. So the way you do that is your first 2x2 is going to be this matrix here. So this is for your X component. Now remember, it needs to follow a pattern plus, minus, plus. So your first matrix will be 2, 3, 2, 1, and this will have the I component. Okay. So that's your plus, then this is going to be your minus, so you have to chuck a negative at the front, and this next matrix will just be this one here. So it'll be 1, 3, 3, 1. So 1, 3, 3, 1, and that will be the J. Then it's going to be a plus, so plus, and then the final matrix will be this one here. If we just rub that out, there we go. This one here, so it'll be 1, 2, 3, 2. So it'll be 1, 2, 3, 2, and K. Okay. Now it's finding the determinant of each of these components. Because remember, we're looking for a vector. We're looking for an X, Y, and a Z. And we can see we're going to get a number here, number here, number here. Okay. So if you take a look on your formula sheet, if you have A, B, C, D, and you find the determinant of this, it's going to be A, D, minus B, C. So pretty much you've got to make the connection. It's going to be these two numbers multiplied, subtract these two numbers. Okay? So you do that for each of these 2x2s. Okay? So for the first one, this one here, let's color it in. It's going to be, so let's go 2, 3, 2, 1. I will be 2 times by 1 minus 3 times by 2, and there's an I at the front. So this is going to be 2 subtract 6 gives you negative 4i. Okay, so chuck that in the corner and let's just rub the rest of it out for now, because we're going to need all the room we can get. Now realistically, you would do this on a spare bit of paper. You don't have enough room on the actual sheet to be doing this in the exam, and this is one of the type of questions that takes longer than a minute to pretty much do. So you don't want to be doing this straight away if you don't know what you're doing. So you would probably want to leave this last. If not, don't do it at all, because it's only worth 1 mark for a lot of working. So find the determinant of this. So it's going to be these two multiplied by each other. So it's going to be 1 times by 1 minus these two times by each other. So 3 times by 3. Now don't forget that huge negative out the front pretty much, okay? And there's a j here as well. So 1 times by 1 is 1. Subtract 3 times by 3 is 9. So you have 1 minus 9, which is negative 8, times by the negative 1, which gives you positive 8. So it's going to be, the next component will be plus 8j, okay? Now we just got to work out the final 3 by 3 matrix, okay? Right, so now we just got to work out pretty much this one here. So it's just 1, 2, 3, 2. Okay, so it's just going to be 1 times by 2, subtract 2 times by 3. Okay, so that k is in front of all of this here. So 1 times by 2 is 2, subtract 2 times 3 is 6, so you have minus 6, so that gives you minus 4k. So our vector is negative 4i plus 8j minus 4k. Now, if you look at all the answers here, you'll see actually none of them match up. This is because they asked for the normal vector. So we do have the normal vector, it's just in a different direction to the answer we have appeared here. Because if you think about it, if we have our plane, right? It's all about a perspective of orientation. So our vector, oh, there we go. So our plane here, it contains 3 points, okay? So we said this is 1, 2, 3. And this is 3, 2, 1. And we were asked to pretty much, alright, work out the normal vector. So this vector here. Now we worked it out to be negative 4i, positive 8j, and minus 4k. However, isn't this also the normal vector? It's just in the opposite direction. Now if you take a look at all the answers here, only one will be in the exact opposite direction. A is the exact same vector, except it's been times by negative 1. So you have positive 4 instead of negative 4, you have negative 8 instead of positive 8, and you have negative 4 here and a positive 4 here. So the correct answer would be A. It's the normal vector, just in the opposite direction, which can be used to throw you off pretty much, okay? And yeah, that's about it for question 5. Let's take a look at the next one. Right, so question 6. 2 coplanar forces, magnitude of 12 newtons and 10 newtons act on an object in the direction shown below. So we can see the 12 newton acts completely vertical going straight down, and we have the 10 newtons acting on a certain angle. So the hard part about this question is working out the components of this vector here, okay? Because if it's getting pulled at an angle, you're going to have a pull this way and a pull this way, okay? Because if you're pulling from a certain point, so some angle here, you're going to have this component and this component to worry about, okay? So the magnitude is going to be the sum of the ups and the sideways forces pretty much, okay? So first of all, we've got to work out this force here. So using trigonometry, this is going to be the opposite side, so this will be 10 sine of 22 degrees, okay? So if you chuck that in your calculator, because I'm actually not sure what that is, what did I work that out to be? We've got it on this page here. So I got 3.746, and that is the vertical direction, so write that as I, but it's going downwards, but it's in the same direction as 12, so we don't have to worry about that. Then we have to look at this component here. So since this is the adjacent side, this will be 10 cos of 22 degrees, okay? So if you chuck that into your calculator, that's going to give you about 9.27. Okay, so if we're adding up all of our forces, we can see that this component here, oh, what's it doing there? Uh-oh. This component is adding with this component here. And then this component here is just a sideways movement. It's not adding with anything. So our vector is going to kind of look like this. It's going to go downwards, but it's going to go sideways as well. So if we were to think about it, it's going to go kind of in this direction here pretty much. Okay, so it's going to go about here roughly in the diagram. Now, the sum, this vector here, is going to be the 3.746 plus the 12. Now, those are in the same direction, so you add them together, and then this sideways here is going to be the 9.27, okay? Now the magnitude of the resulting force is this force here at the particular angle. So all we have to do is Pythagorean's theorem. So what you're going to do is work out that side there. So that side F will be the square root of 9.27 squared plus this result here. So 3.746 plus 12, and that's all in a squared. That's very messy working, but it is what it is. Now if you calculate that, you're going to get about 18.266. Now you can see here that answer doesn't match, that doesn't match, that doesn't match. This one does if you round it, okay? So that's the correct answer. Righto, let's go on to the next question. So, question 7. The matrix N represents the result of a competition involving 4 teams, okay? So, straight away looking at this, we're going to be using a dominance matrix, okay? Because you've got a couple ties here. So, for example, this team is tying exactly with this team. They both have 2 points if you're reading it like that. So, using the ranking model, N plus a half N squared, the teams are placed first, second, and third respectively. So, we're trying to work out who won, pretty much accounting for half points. Because remember, this number in front of the dominance matrix here represents the weight of a point, okay? Since they point 0.5, that means it's a half point. If it was like 0.3, then it's like a third point or whatever, stuff like that, okay? So all you got to do, remember, this is a calculator test, okay? So what you want to do is you want to type out this matrix here. So go 0, 0, 1, 1, 1, 0, 0, 0. Oh, that's a bit too small. What is it now? 1, 0, 1, 0, 0, 0, 1, 1. So that plus the exact same thing. So that exact same thing, and you want to square it, and you want to times this one by 0.5. You want to chuck that into your calculator. Now, if you do chuck it into your calculator correctly, what you're going to get is this following matrix. You're going to get 0, 1, 1.5, 1. You're also going to get 0, 0, 0.5, 0.5, you're going to get 0.5, 1, 0, 0, and then you're going to get 0.5, 1.5, 1, and 0, okay? So you're probably wondering, what does this actually mean? Well, this is the pretty much accounting for the half points of your dominance matrix, okay? So what we can do here is we can add up the rows and see who's actually won. So you've got to remember the order they're in. So looking at our matrix here, it goes P, Q, R, S. So it goes P, Q, R, S. So what we can do is work out the sum of each of the rows. So add all these numbers up together. So that one will be, what would that be? That would be 1 plus 1.5 plus 1. So that's going to be 3.5. Then it's going to be 1 plus 0.5 plus 0.5. So it's going to be 2. Then it's going to be 0.5 plus 1. So it's going to be 1.5. And then you're going to have 0.5 plus 1.5 plus 1. So that's going to be 3. Okay? So we can see here, P, Q, R, S, there is a direct order if you account for the half points pretty much, okay? Now remember, they want you to place the teams in terms of first, second, and third respectively, okay? So even though there's 4 teams, you don't need to place all 4 of them because we know who the loser is going to be. It's R, obviously. So we can see here, P's 1, so it's going to be P, then S came second, so S, and then Q came third. So you look for the one that has that. So P, S, Q, that's it. And that's done, okay? So this one, definitely calculator heavy, pretty much, okay? Righto, let's take a look at question 8. So, given f of x is tan inverse of 2x, determine f dash of 3. So basically, you've been given a function and you want to work at the gradient at this specific point. So when it says f dash of 3, that means differentiate this and substitute x equals 3. That's another word for it, okay? Now, using this, you gotta use a chain rule. So if you have tan inverse of u and you were to differentiate that, that's going to give you u dash over 1 plus u squared, okay? Now u represents the inside function. So in this particular example, u is going to be 2x, okay? So if u is 2x, then u dash would be 2. So you're going to have 2 on 1 plus, remember this is u squared, so it's 2x all squared. So it's going to be 2 over 1 plus 4x squared, okay? So this is what happens when you have tan inverse 2x and you differentiate it. So that's what the dash pretty much means, okay? Now remember, if this is f dash of x, you want to work out f dash of 3. So you want to substitute x equals 3 into this equation here. Okay. Now, if you do that, you're going to get, we run out of room very quickly. So you're going to have 2 over 1 plus 4, 3 all squared. Chuck that in, that's going to give you, what is it, 2 over 37, okay? Now, if you put that as a decimal, that's about 0.05, okay? So you can see, bingo, that's the correct answer there. 8 is A, okay? And that's how you answer question 8. If you have any questions about this one here, leave something in the comments and I'll try my best to answer it, okay? Right, so let's take a look at question 9. So we're almost there. The time in minutes between the arrival of customers at a certain shop is to be assumed to be a random variable x with an exponential distribution that has the probability density function, blah, blah, blah. Okay? A customer arrives at the shop and the probability that the next customer arrives within 30 to 60 seconds, the nearest percent is. Okay, so it's a probability density function. So we're immediately thinking area under curve is the probability. Now, when I sat this test before, I actually got this question wrong, mainly because I didn't look at this, minutes and seconds. So this was the only one I really got wrong. But you've got to look for these sneaky little things that pop up because they'll trick you all the time. Okay? So what we have to do, if this model is in minutes, you have to convert this to minutes as well. So 30 seconds is half a minute. 60 seconds is 1 minute. Okay? So what we're doing is finding the area between 30 to 60 seconds. So it's the area under this curve, so the integral between a half and 1 of this function here. So 0.12 e to the negative 0.12 x dx. You can actually chuck that into your calculator or you can do it by hand. Since it's a calculator test, you want to do it in your calculator. That way you save a bit of time pretty much. So if you chuck that into the calculator very quickly, you should get 0.05 48. Now remember that's an area, so if you want a percentage, you want to times that by 100, so that'll give you 5.48%. Now look at the wording here, to the nearest percentage. If you were rounding this, you would round it to 5% because it's 0.48. So it's not 5, so you don't have to round up. So the correct answer is B. Okay. If you have any questions about this one here, leave something in the comments and I'll try my best to answer it. Okay. Now let's take a look at 10, the final question. So this one has to do with complex numbers. Now this one will probably take a bit. However, if you're very good with your complex numbers, it won't take you too long. So we want to convert, pretty much, we want to work out what the fourth root of this complex number is. So what we can do is change the z. So z in polar form is r, the distance from the origin, cis, so cis represents sine and cos theta, okay? So if we substitute this into here, what we're going to have is, all right, z to the 4 equals 16 cis 2 pi on 3. So that means you have r cis theta equals 16 cis 2 pi on 3. Then what we can, I forgot the power of 4. We can use de Moivre's theorem, so you can apply that power of 4 to the r, and you can bring that 4 inside the theta. So you have r to the 4 cis 4 theta equals 16 cis 2 pi on 3. Now what we can do, because they're the exact same thing, is you can equate this is the same as this, and this is the same as this. So you get r to the 4 is equal to 16, and you get 4 theta is equal to 2 pi on 3. Now, don't forget about the rotation. So it's going to be a plus 2k pi, where k represents a real number, okay? So it's a rotation because you're going around multiple times, okay? Now, if you take the fourth root of 16, it's going to give you 2. So, and then you've got to divide by 4 here as well. So if you divide by 4 here, you're going to get theta equals 2 pi on 12 plus k pi on 2, because that 2 over 4 will turn into a half, okay? So basically, your solution to this thing here would be z equals 2 cis 2 pi on 12 plus, what was it? I forgot what it was. It was k pi on 2. There we go. K pi on 2. And to work out your solutions, you substitute k equals 0, 1, 2, and 3. So just your first 4 solutions. Now, taking a look at the answers here, the radius of your complex number is 2. So if you're looking at the first two answers here, they're on a radius of 4. So it can't be either of those, okay? So it has to be between C or D, pretty much, okay? Now, what we can do is work out the first solution. So substitute just K equals, let's go K equals 0. That'll be the easiest, okay? So if you substitute it in there, you get the complex number, what is it, 2 CIS, what is it, 12 pi, 2 pi on 12. So, oh, we've run out of room. Oh, wait, let me rub it out. Just one moment. So 2 CIS 2 pi means 2 cos 2 pi on 12 plus 2 sine of 2 pi on 12i. Okay, so if you chuck this into your calculator, we'll see what we get pretty much, because I'm not sure what it is off the top of my head. So that would be the square root of 3 plus, and I'm pretty sure this is going to be 1. I'll double check it as well though, because you get, yeah, it will be a half. So 2 shift on 12. So you get 1. So it'll be I. So this is your first complex solution. Okay. So first of all, you want to see, all right, I. That's the vertical component. So it's going to be halfway here. So we can see, all right, that one's halfway. This one isn't halfway at all. So that doesn't match either. And just to double check, if you put in the square root of 3 into your calculator, it should be about 1.7, I think. Now we can see that's pretty close to 2. This one is fairly far from 2. So that also justifies why the correct answer is C. And that's it. That's the multiple choice question for the Specialist 2023 External Exam, Tech Active. Okay. If you have any questions about the stuff I've covered in this video, leave something in the comments and I'll try my best to answer it. Okay. But in the meantime, I'll see you in the next one.